and I'm a data analyst. In this video, I'll be walking you through various numerical data issues and how to handle them in our programming language. One thing I believe is that if you digest these techniques that I'm going to be showing you, you should be able to work effectively with any type of numerical data. A few days ago, I posted the Python version of the course on this same channel, Damks Analytics. So, and I believe as a uh, data science or a data scientist or the data analyst, one of the key requirements is to be proficient in at least two programming languages. So, having knowing how to handle the cases in both Python and R programming language is very, very important, which is the primary goal of creating this video. So, uh, so these are we'll be dealing practically with several types of data issues. Of course, we have the eighth one, which is the data integrity issue. And this is more or less of theoretical stuff based on it's more or less a backend issue, from database and the likes. So these are the issues that I will show you the type and how to deal with them in our programming language, which is data type mismatch, missing data, unexpected values, scaling consistency, inconsistent format, categorical data encoding, duplicate data, and the likes. So these are the ones that I'm going to be showing in this video. And without wasting time at all, let's get started actually. And permit me to use this opportunity to thank everyone that have subscribed to our channel. Thank you so much. So it shows some level of encouragement to create free courses, because that is our goal, to make learning available to everyone. So, and if you are yet to subscribe to our channel, please, we're sending out the invitation to you to do it, to subscribe to our channel, like the video, share, and comment, and let me know whatsoever you think about the courses. Okay, so let's get started. So first and foremost, let's create a sample data frame to show how this type of issue, how it looks like when you are dealing with your real world data. Okay, so let's say we have df equals to data frame. Then inside that we have, let's assume we have id, right? Id, then we have c to concatenate. Then 1, 2, 3, 4, 4. Then we have another variable called value, and inside that we have, so this is the data. Now if we run this, so let's run and see. So this is the data. Now we can see the issue explicitly, in the sense that this is a strange, this is strange, this is strange, why this is a numerical data. So when our programming language reads the data, it assigns character data type to this column value, of which its content actually is numeric. So this is a type of data type mismatch issue, data analysis, and there are many ways to solve this. But one easy way to solve this, I'm going to show. In the first place, how you know that you have data issue is by checking the data assigned automatically by how programming language. Now in this case, we can see that the column value has CHR, which stands for character, as its data type, which is wrong, because you will not be able to perform any mathematical any mathematical operation on that being, having character as its data type. So there's a problem to be solved prior to further data analysis. Now, the DBL that we are seeing here means double precision, and it's actually a quantitative variable that is essentially continuous taking decimal values. So that is, the term that our programming language uses. So now to solve this issue in how is very easy. It's as easy as a single line of code, and I'm going to be showing you right now. So what we are going to be doing basically is that we'll be forcing the value column into numerical data type, and this is how you do that. So you have to specify the name of the column, then equals to as use the as numeric function numeric, then you indicate the name of the column. So let's see now. So from the after we have used the as numeric, which actually force the column into data type, you can see that the data type of column value has changed to dbl, and now we can compute any mathematical operation with that column. You can see from character chr to dbl, and your data is fine now, and you can go ahead with any further data analysis. So the next one that we'll be treating right now is called missing data. So missing data could be in form of NA or none or empty. We shall be solving this issue in two ways. Now, one way is dropping of the affected rows, and the second way is the imputation of whatsoever you want. Then dropping the row is acceptable if there are very few cases. Imputation or interpolation in other domain is preferred when there are too many cases. And now you have to note that if there are excessive missing data, just discuss such data, because you may actually end up developing an inaccurate model. So when the missing data is too much, discuss it. So let's see that type of issue. Let's use the same sample data frame here. Just change one or two things to make it relevant for the present case. So we have, let's say this is numeric. Then let's say let's make this n here, right? And this numeric. Let's run this and see what we have. So the data tells us that we have issue of now NA not applicable. So in our data, and of course, in some cases, you could go ahead with your data analysis and see there are some module that will just exempt this row that is being affected. But in some model, it will flag it for you that there is an issue in your data. So first thing that we will try to do right now is to drop this row, the row that is affected, and then in the second scenario we will do imputation. So we'll be using the na.omit function in our programming language, and this is let's say we have df clean is equal to na.omit, then the name of the data frame, as simple as that. Now let's check what we have again. We run it. Oh, sorry, we had to print out df clean, not df anymore. So if we do this, nice. So that's actually drop row 2, which is the affected row. Then let's try the imputation right now. Yeah, data imputation basically is a way of substituting the NA values with a particular value of our choice. Now in this case, we want to substitute a mean of the column, and this is a bit tricky, but I will explain. So we'll be using if x function to perform that operation. and this is one way to do it. The name of the column is equals to uh, let's say we have, yeah, this is if x. I'm gonna explain to bracket is none, then it is this value. Then we have the main, we have the have value. In this case, we are setting none equals to true. Okay. Then from here, have the have equals to value. Now, so let's try to run and see if this works well. Error object true not found. Let me check if it's because of the way I type this. Let's check now and see. Oh, cool. So everything is fine. So this ran successfully. Is that it substituted the average value of this column for the NA values. So I will explain this line of code that you will be able to understand what I've actually done. And now, if x is a conditional function that allows us to eliminate, like it allows us to perform element-wise conditional operations on vectors or data frames. Now, the syntax basically is this. We have, let's say we have syntax is like this. So what does this mean? This means that this this returns a value with the same shape as test. The first parameter, which is filled with the elements selected from either yes or no, depending on whether the element of test is true or false. So in other words, if NA, now come back to our issue here, if NA is found, it executes the second argument, which is if NA is found in this data, then it executes this value. Then if reverse is the case, right, then it executes this. It returns the same data as we have it here. So that is this is basically what if X function is a very powerful one, and I use it very often in my issues when dealing with data missing data and some issues in data analysis. So it's very powerful. You may want to read more on if X function. So one more thing that I would like to add is that the values that we have in this column, we have them in how many decimal places now? This is 5. So I mean this doesn't look so good. So we can solve that issues by using the floor function. Floor function, just put floor here. Put everything in the bracket. Let's run it again. Let's see. Oh, nice. So this looks nice, alright. So that's actually cut off all the decimal places, and this is pretty much more presentable. So now the next data issue that we're dealing with right now is unexpected values. Unexpected values could be any weird symbol in your data. It could be a question mark, be a dollar, it could be, I mean, it could be any weird symbol. I've seen many cases of data like that. So, and dealing with that issue is a bit different from the case one and the case two. And I'm going to be showing you how to deal with that kind of data shortly. So let's use the same data, the same sample data we used earlier. From here, just make some modification to it to suit the issue that we are dealing with at the moment. So in this data, instead of NA, let's put question mark. Let's put question mark. So let's run it and see what we have. So we have question mark in our data and R has assigned it respectively character data type to that column value. So one thing that I need you to know is that if you try the solutions that I've shown you in the case 1 and case 2, such as in the missing data, like let's say we're dropping the affected row, it's not going to work. It's not going to work. And why it's not going to work, let me show you. Let's first and foremost try to drop this row 2 and see if that works. Then let's say we have df clean, right? Df clean and a dot omit, right? Then the name of the data. So let's see, we have, unfortunately, nothing changed. We still have the question mark in the data. We still have the question mark. So one way to solve it is to force this column, value column, to force it as numeric. So when we force it as numeric, it will change this question mark to NA, not applicable. So from there, you may now choose to drop or to input to do imputation. Now let's try that and see how that goes. We have as numeric, we have nice. So now it has changed this question mark to NA. Secondly, it changed the data type from character CHR to DBL. So now it has changed it from character to DBL. And now you may now choose either dropping the row or doing imputation. Okay. The next data issue that we'll be working on right now is what we call scale inconsistencies. And this is when a feature or a column values are excessively larger than the other features. So, and why is it important in the first place? Because now scaling the data can help to balance the impact of all the features on the distance calculation and can help to improve the performance of the algorithm. So basically, I've had several issues of this type of scaling consistency. I mean, I remember when I was a junior data analyst, I had several issues like this of scaling. So, how do we deal with this kind of data? Let's create, it's a bit different. So, let's create a new second feature. This is feature 2. It's, so, the value is 0 0.1, 0 0.5, it's 0 0.9, and 2.0. Let's check the data and see what we have. Okay, cool. So we have two columns, feature 1, feature 2. Feature 1 value ranges from 100 to 400, while the feature 2 has value in the range of 0 0.1, 0 0.5, 0 0.9, 2.0. The margin is too wide. To solve this kind of issue actually is as easy as a line of code using the function called scale function. So how do we do this in R? So let's say we have df scaled, right? And it's equals to scale function. Then just put the data frame inside this as the argument. Then let's check scale Oh, nice. So now it has actually changed the scale of the two features, and they are both now on the same scale. This helps to prevent some kind of weird issue in your model development. Okay. So the next one that we'll be dealing with right now is inconsistent form. So inconsistent format, actually this happens mostly in time series data. Uh, one tricky thing that this type of issue is, I mean, one tricky thing about this type of issue in data is that they are usually invisible. You don't know that you have several issues in your time, your dates, most especially in your date. So it is when you have worked to some extent, the model will start complaining of some inconsistent formats. So what I usually do, I assume, I mean, just like in the case of the data that I am not sure of its origin, I assume that there are inconsistency in the data, and I treat that data before I proceed with further analysis. So let's create some sample data frame to see how this kind of issue actually looks like and how to identify them. Now, let's assume that you have this type of data. So with date time column, now you can see that the format here is different from what we have here, different from what we have here, different from what we have here. So now we have inconsistency in that data, and that will give us issues when we are doing analysis because we will not be able to reference correctly. So let's run this and see what we have. So this is what we have in the data frame, and we can see that some data has IV and some with slash as their separator. So if we use, our programming has a function called as date. So as date function, it's not going to work on the data because I mean it is beyond what it could actually cope with. But I will show you the step by step of how to deal with this kind of issue in our programming language. So first and foremost, let's try to apply a state function to this problem and see if it solves it. And this is how to do that in how. So have it. Then we have function called state. Okay, it's here already. Then what you need to do is to indicate the name of the column, comma, then the format that you want. So we're gonna be choosing here separator slash one. It's okay. So this is the have, right? It's running. We have this did not solve our problem, although it changed the data type to date, but we have weird value of now everyone. So the next approach now is to use the lubridate library, so which is very handy in dealing with, I mean, date time data. So the first thing that we need to do here, so I think I have it already. Like, just let me show you how to do that. Install that packages. Then you put the name of the package, which is lubridate, if I'm right. Yeah, lubridate. Then the next thing is to call, to import the. I already have it, so I'm not going to run it. I'm just going to comment it out. So I will only run the lubridate. So this is imported. So let's just copy the data up here. Just copy what we have here and here, right? So the next thing that we have to do right now, let's run this data again so that we have fresh data with issues. So I will show you how to solve this. I will write the code and I will explain what the line of code actually does. So let's say we have P1, one, and column. Let's just specify the separate side month, date, y, and specify the column. Then the next thing now, I mean, you should have an idea of what is going on in this line of code, but however, I'm going to explain to you because we've used the ifelse function before. Okay, so let's try to run and see what we have. Do not find. No, excuse me. It should be hell, not one. So this solved our problem of formatting, right? So now from this you can see different formats, right? With character, data type. Now after writing this code changed the format for us very well. You know, we now have a very common format in our date column. Now, so what happened in this code is that, let me explain what I just did. I use the ifelse function coupled with grepl is a function in R. You can Google it. Function. So the grepl function stands for grep logical. In R, it is a built-in function. It is a built-in function that searches for matches of a string or string vector. I already explained the operation of ifelse for you earlier. So what the code actually does is that it searches for a particular date format. In this case, we are using the slash. So then when found, it changes the format to the specified in the yes parameter, which is what we have here, yes parameter. So it changes it to this format. But if no, then it skips that row, meaning that is this format that has actually found it has actually found. So it skips it, then next uh go for the next row and search. So, but now problem is not completely solved, but 70% solved. Now, how to because now we have data type showing here as character, so we need a date time, I mean, a date data type here for us to be able to manipulate this row to work with this column effectively. So that is when the as date function now comes into play. So it's the one that is going to change the data type for you from character to date type. So let's see how that works. You know something? Just let me copy from up here. Yeah, let me copy from here. Here, let's put it here. So let's change this to hyphen. So now let's run this. Let's see what we have. Perfect. So it has changed the data type from character to date, and our problem is completely solved. Now you can move on with your further data analysis on your data. The next data issue right now is categorical data encoding. So yeah, most times the models they don't take in test data. So what we normally do is that we encode the test into numerical data. So now in how you can encode categorical data using various methods actually. One common approach is using the factor function for ordinal data, and the other one that I use mostly is model matrix function for nominal data. So And I hope you know the difference between the ordinal and nominal data though. So, but let me quickly refresh your memory about that. So, ordinal and nominal data, they are both categorical data, right? So one is with order and the other has no order. So e.g., I, medium, low are example of ordinal data, while female, male, an example of nominal data. So let's create a sample data frame with this kind of issue. Let's say we have data frame, and in this we have salary column, which is equals to 14. Then we have the second column called category. Okay. Then we have this. We have low data. Let's see. Yeah. So cool. We have two columns, salary and category. So so first and foremost, let's convert the category column to ordered factor using a factor function. Okay. So, and this is how to do that in R. So we have df category is equals to factor then you put the name of the column again, category, comma, levels equals to C. You indicate the levels that you have in any order that you prefer, ascending or uh, descending, low, medium, high. Low, medium, high. Then here we have to indicate that we should order it for us. Ordered equals to true. Yeah, true. Usually have that issue of lowercase true. Let's check if they solve this problem. Yeah. So we have just changed the character data type to other data type. So that is one. Then the other part of it is that for the nominal data, we have to use the model model matrix function to solve that issue. So now for the nominal data issue, so we're going to be using model matrix function. And let's assume we have this type of data. So we have a score. Let's run this and see. So we have score and category and columns in this data. So this is a typical example of nominal data. So now to solve this issue is very simple. So let's have a new df encoded, right? Then what is it called? Yeah, as as data frame as data frame model dot matrix the matrix. Then you input this word signs. Since I'm going to explain what this line of code actually does. Okay, so we have -1 comma data is equal to no yes data is equal to df. So we can move up. we have an error in our code. What is the error? Oh, I think we have double parentheses here. Let's run again. Oh, cool. So now that's transformed each of the cases into in Python we call it a one-hot encoding. So now we have each of the category as a different column entirely. So with this, you can feed this into your model and you shouldn't have any issue at all. And I would like to explain what the code actually does. I mean, this line of code in the sense that now we use in the first case of categorical data encoding, we use factor function to convert the category column to an ordered factor with specified levels of low, medium, high. Okay, you may choose high, medium, low. The choice is yours. So this is suitable for ordinary data where there is a meaningful order. Okay. So now in this example, so we use model matrix to perform one hot encoding for nominal data. So and this minus one that you see here in the formula, it removes the intercept. It removes the intercept term. Okay. So these methods are the most common scenarios for encoding categorical data in R programming language. So the last but not the least data issues that we'll be treating right now is the duplicate data and how to deal with them in now duplicate data basically deals with repetition, and repetition can be removed from data in two ways in R programming language. The first method is based on all the columns present in the data. Then the second approach is based on a specific column. So it depends on the column that if you are concerned about a particular column, then you don't need to drop. If you are concerned about the repetition in a single column or in a particular set of columns, then you don't need to drop the repetition in all the data. So those are the two ways that I will be showing you on how to deal with them in our programming language. Let's assume we have this type of data. Let's run it and see what we have. So we have duplicates in this data, and it shows that we have one this record and this record are the same. So we want to drop this duplicate in our data, and how do we do that? To drop duplicate in the data frame, in the entire data frame, is very simple, and we'll be using the unique function. So let's say we have this one is no duplicate. Now duplicate is equals to no duplicate is equals to uh yeah, unique. They just put the data frame inside as the argument. Then let's say we have df no duplicate. So what do we have? Nice. So now in this case, it has actually removed the duplicate. So we have 220 and is the only one in that record. So the other method is that we can use the duplicated function to identify the duplicate in our data and then subset or remove them based on your specific needs. All right. So one way to do that is let's for another chunk. One way to do that is to use first and foremost. Let's identify the duplicate in the data, and let's say duplicate. Let's say duplicate. is equals to duplicate is equals to uh, this. Then we put the data frame bracket. Then we use duplicated function, def, the comma. So from this, let's print this and see what we have. So this is showing us that we have a duplicate at index 5, and is this is the only duplicate that we have in the data. So if you have more than one, it's going to identify it for you. So the next step right now is to drop it. We actually drop the duplicate by the ID column. Okay, you may choose any other column that you are concerned. So now I'm going to be using ID column to drop the duplicate. Now let's say we have df dup by ID. Okay, is equals to df. Then you use this exclamatory mark, duplicated, duplicated. Then you specify the column you are using. So ID, comma, let me check. We have dup by ID. Let's see what we have. Nice. So we have similar result, but in this case, we dropped the duplicate by ID column. So one thing that I would like to call your attention to right now is that the choice of which duplicate to keep or remove will depend on the context of your analysis. So you decide the column that you want to drop the, uh, the the duplicate by. Okay, so yeah, basically these are the main data issues that I want to show you and how to deal with them in how programming language. So the eighth issue is the data integrity issue, which is more or less of theoretical stuff. So this is more or less of a back end issue, and it refers to the accuracy, consistency, and reliability of data in database or data set. So data integrity issue occur when there are discrepancies. I mean, inaccuracies or inconsistency in the data. So this leads to a lack of trustworthiness in your data. So and it can arise from various sources and may impact the overall quality and reliability of the data. So yeah, in short, it's just a backend issue. So thank you so much, and I hope you learned one or two things from this video. So feel free to to like the to like the video, comment, let me know what you think. I mean, what you think could be added or how to improve the video or something. So just let me know what you think, and don't forget to subscribe to our channel. Thank you. My name is Oluwasegun Adebayo. Bye.